UCA is a special place in its own right, really, because when a student joins a course here, they're not just joining a course, they're really joining a creative community. Some of the kind of more unique areas of the course are the fact that it's a product design course mixed with some of the interaction aspects, sustainable materials. Those bring into play very much looking at the user and user focus for how we design products. I chose to study product design at UCA Farnham because of the facilities we have here. There's a glass hot shop, we have a metal workshop, there's a dry workshop, we even have a plaster room, and all these things are just exciting. You know, I really wanted to get in and go play around.
It's such a different experience than what you would ever expect. Obviously, the course I'm studying, silversmithing, is a unique course in itself, so the university has to supply for such an individual course. It provides so much in terms of equipment and facilities, in giving us many experiences.
I chose the course because it was really friendly, got a good vibe when I came here. I looked around quite a lot of other unis, but this one I kind of just didn't feel intimidated by. It was really nice.
The atmosphere in the studio is excellent. Many of the students mix and match very well with a mixture of international and UK-based students.
In my second year, I'm looking to do an international student exchange to Barcelona. In doing so, I'm looking to increase my confidence and understand the international market better.
The way the course is structured is it's hugely independent work, so it's very self-reliant. There are certain one-on-ones with the tutors or group meetings, and in fact we do have one lecture a week which normally builds up to an essay at the end of the course. That is usually some very in-depth about the psychology of objects or what people see in jewellery and stuff, because we need to know how to sell to the client.
Our technicians are really inspirational because they know so much, and there's not many of us on the course as it is quite a small, compact course. So having two technicians constantly is really great as well.
So a real range of different industry practitioners come in, and it just gives students the sense that what they're studying is for real. They're learning things that are being used currently in the industry, and they're learning processes that are being used and that are valued by the industry.
In terms of networking opportunities for students, these are becoming increasingly important. I mean, it's always been recognised that it doesn't really matter how talented you are, you actually need to get people to see your ideas and see your work. And now the opportunities for students to network are ever increasing with the increase in digital technology, the opportunities that are available through social media, and we use those very much as an integral part of the course. So if you want a good start on a product design career, UCA is the place to start. It really gives you a professional experience and it sets up the awareness of the student right at the beginning.
Alright guys, so that was just a little three-dimensional design video that I saw, and I am going to be talking about lines and whatnot and angles today, and a lot of this has to deal with three-dimensional objects, so I thought it was appropriate. And you know, you talk a lot about times in class how, when am I going to ever use this, where could you see this in the real world, well there's a perfect example if anybody's artistic and enjoys sculpting things, three-dimensional objects, so on and so forth, okay? Let's continue on. So we're going to start with some parallel lines. As you saw that video, you saw a lot of people creating constructions, this and that. There were a lot of uses of parallel lines throughout it, okay? And it's just two lines that are coplanar and do not intersect. So you're looking for two lines that just go in the same direction forever and they never touch one another. I know I've talked about this in class before, but you see these little arrows, okay? They're just like showing that lines are parallel. That's all it means, all right? So super easy, we've done it before, you get the idea. This is the one that's kind of new. Skew lines are lines that do not intersect and are not coplanar. Here's a three-dimensional box, okay? If I have a line out front here, like so, and I have a line up top, like say here, that would be an example of skew lines. They're lines that are not parallel, but they're also never going to touch each other. And if you look at this three-dimensional object, this one's way up top, this one's down low, they won't hit, okay? Parallel planes would be like the sides of the boxes, the tops of the boxes, the front and back of the box, because they're parallel planes. Planes are like tabletops. And lastly, a transversal is a line that intersects two or more coplanar lines at different points. We'll take a look at that as well. So name all the lines parallel to RV. Here's RV, so parallel lines would be all of these lines going straight up. So you're looking at QU, TX, and SW. You'll notice that I put double arrows on top because what lines stand for. Alright, if you did UQ or XT or WS, you're fine as well, but these are your parallel lines to RV. Name a line perpendicular to SW. It's a line that intersects at 90 degrees, so you're looking at TS, XW, you could have RS, or you could have VW. Now again, I understand it says name one line. I just gave you all of them in case you wanted to check out one on your own. Okay. And as far as QU goes, you're looking at lines such as, in the back here, TS, XW. Okay. You're looking at lines like SR and WV. Okay, those are all lines that, here's my line QU, these lines are cutting this way, and they'll never intersect with QU. Okay? Alright. Parallel postulate. If there is a line, a point not on the line, then there's exactly one line to the point parallel to the given line. This is like if you were ever asked to draw it. Here's a line. You can pick any point you want on the entire spectrum of the geometry or in anything, a plane. And if I have a point off of it, I'm allowed to draw one line that is exactly parallel to this one. That's all. Okay. Same thing for perpendicular postulate. I can have a line, I can take a point off that line and draw exactly one line that's perpendicular to that point in that line. That's all. This is your big thing, and this is what we're going to focus on the next few days in class, make sure we're all comfortable with. And let's take a look. You've learned this before. This is not something that's new for you. It's been a while since you've seen it. I do agree with that, but you should be able to remember this. Corresponding angles. Occupy corresponding positions. Look at your top four here. 1, 2, 3, 4. Top left, top right, bottom left, bottom right. Can you guys all agree with me that 1 is your top left angle? Now look down low. 5, 6, 7, 8. Top left, top right, bottom left, bottom right. 1 is my top left. 5 is my top left. They occupy the same spot, the same position. So corresponding angles would be like angle 1 and angle 5. You could have also said angle 2 and angle 6. You could have also said angle 3 and angle 7. You could have also said angle 4 and angle 8. Okay? Alternate exterior angles. Now, with all these angles being formed, again, this line T is my transversal cutting through it. Lie outside the two lines on opposite sides of the transversal. So if I close this off, a little dotted lines. See how I have a 1 outside here? If I go outside and across it, 8. So angle 1 and angle 8 are alternate exterior. You could have also said angle 2 and angle 7. Very nice. Alternate interior. Same idea but on the inside. 3 go across and 6. Could have also said 4 and 5. Okay. Finally, they call this two different names: consecutive interior or same side interior. Probably the more formal word name for it is consecutive interior. Same side just kind of spells out what it is. You're on the inside, you're on the same side, or consecutive. So angle 3 and angle 5. And again, you could have also said 4 and 6. So down here it says draw 2 lines in a transversal. Now, I'm going to go ahead and draw it like this way. Here's my 2 lines. Here's my transversal. I'll call this T. Here are my 8 angles being formed, which, by the way, is what you'll always get when you draw 2 lines in a transversal, 8 angles. Identify a pair of alternate interior and a pair of alternate exterior. So here's alternate interior. Here's alternate exterior. Interior is on the inside. So I'm looking at like 4 and 5 for interior. Exterior would be like 3 and 6. And if you drew this picture differently, you could have a different set of angles. It's totally fine. Please note that not every picture is going to look like this or like this. I can move it all the way around. I can shift it around, rotate it, reflect it, whatever it may be. Okay? On the back. Here's another 3-dimensional object. Okay, it's like a 3-dimensional trapezoid, if you will. Identify a pair of skew lines. I'm going to give one example. There's tons of them. Here's DC going across. Here's HG going this way. They're not parallel and they don't intersect. So DC and HG. I'm curious if you guys would like some practice. Go ahead and see if you can figure another pair of skew lines here and come up and show it to me. And I'll go ahead and tell you if you guys are ready or not. Okay? Parallel lines, looking like AB and DC. There's one example. Again, there's tons of other examples in this picture. Feel free to go ahead and try to pick out a pair and come on up and ask me. Identify a pair of perpendicular lines. This one's a little more tricky. You're looking at something like AD and DC. Okay, they make that right angle right there, and I'm assuming that's the right angle. I know I told you guys in class not to assume. For the sake of this picture, because of what they've given me, I can't. I would not say DF and FG, but there, because it looks like a box, I can assume that. Okay. Finally, using knowledge of perpendicular lines. What does this little box mean? I'm hoping you guys are comfortable with that being 90 degrees. All right, these are across of one another. So x plus 38 equals 90. Subtract 38 over. I get 52 degrees. And all is well. Sorry for the lighting right there. I don't know why it's so glary. But it's looking good. Now this one, you might be inclined to do the same thing and say x minus 12 equals 90. But please note, see how these are back to back? Okay. Straight line's 90. You could do this plus this equals 180. Alright. But you also know that these two have to add to 90, just because they're next to that 90. So x minus 12 plus 49 equals 90. 49 minus 12 is 37. Degrees. Just to show you guys this super quick, if you really would like to keep things kind of similar, you could also do this, x minus 12 plus 49 plus 90, like the whole thing equals 180. Because look what happens if I subtract 90 over. I get exactly the same thing. So whatever way you prefer to look at it, you're totally cool. That'll help you out, and you should be in good shape. So big things for today, these little notes. All right. Please note what skew lines are, lines that are not parallel and they do not intersect. So they're only existent on 3D objects. That might be a good thing to note down there. All right. Also, I'm going to really focus on these the next couple of days. Corresponding, alternate exterior, alternate interior, and consecutive interior. All right. So please be aware of that. If you have any questions on this, please don't hesitate to ask in class, because they're definitely going to be popping up again. All right, so those are a little bit of notes. I have a little bit of homework for you guys, and that wraps up our day for today. And as always, keep the good work and good luck. We are all counting on you.